So my name is Curt Smith. I'm the development manager at Microsoft for what we call the team is called specialized compute. So my team builds infrastructure software to bring high-performance computing systems to Microsoft Azure. So these are systems that have Mellanox InfiniBand as a second back-end network. In addition, my team also builds the infrastructure to enable all of the GPUs that are in our fleet. So we have Kepler, Pascal, Volta. I've got a couple services. One's called Azure Batch. We're in preview with another service called Batch AI Training. And I've got teams in Shanghai, Wellington, New Zealand, kind of spread around the US. And so our journey in Microsoft and my journey in the oil and gas industry is kind of what I kind of spend a little bit of time with you guys today and go through that. First, I'm going to start with my journey. And one of the things that I've met with some of you guys, we've been spending a fair amount of time in our world, trying to get into understand the workloads, the scenarios, the challenges, everything that's going on in oil and gas. I got to tell you, I'm not a marketing guy. You're not going to get a marketing deck. I'm the development manager. I don't know why Keith invited me, but he did. So you're going to get something that you may not expect a little bit. So what's my journey? So first thing I've learned when I've talked with you guys is show me the capabilities. I will derive the benefit. So you're going to get the feeds and the speeds. Second thing, HPC is normal compute for your industry. When you look at the evolution of the cloud, if you go back to the very beginning, they talked a lot about things like compute units. And one of the challenges when you go to an HPC customer is they're like, dude, I've got 30 petabytes and I've got how many megawatts and I can't tell you how many petaflops. It goes up every year. And you come to them with an undifferentiated compute unit, and that doesn't really resonate. I've been there with you guys. As you have also been with probably all of our competitors, Amazon, Google, Microsoft. It's uninteresting to the extreme, right? The other thing I've heard is that we've been doing IoT for subsurface since 1927. Don't talk to me about IoT. Right? That was when the dip meter came out, right? From Schlumberger in 1927. And then this one's new. This one's come up in the last year. Because I run all of the software and the infrastructure for the public cloud for our GPUs. And you may or may not know that we have 5,000 AI researchers in Microsoft Research. I have a mandate to add AI to everything. Can you help? I see some people laughing bigly. You know what? Okay, this is not just you guys. Literally, so I spend about 30% of my time talking to CIOs, engineering teams, just going out and talking about our stuff. Every single customer that I talk to, every single one, asks me, hey, I have this mandate from my boss. I don't know what it means. I'm not going to name any names here, but I had someone ask me, what is a data scientist? Who's a very important person in your industry. How would I hire one? What does a resume look like for a data scientist? I only know physics-based modeling. And so we actually did a workshop with them, sent them off to monster.com and helped them figure out where to hire, but there's a lot of hype. There's a lot of hype. So I'll talk a little bit about where I see people being successful with this stuff and where I think there's just a little too much on the, too much that's not really realistic. So I'll really briefly on this slide, the cloud challenges for all of us, it's basically large data volumes, the compute scale, and the latency. When you purchase something from a cloud provider, what are you getting? You're getting a virtual machine typically. You don't own it, you're renting it. You may make a commitment for 3 years to rent it, but it's like leasing a car. At the end, that thing's gone. But one of the disadvantages is that when you use a cloud provider, like us, like everyone else, for most things, what you end up with is a challenge where you're not going to own the root password of the host. You're renting virtual machines. So what you get is higher latency for almost all operations. The other thing that's kind of, I think, a bit of a challenge in the journey for everybody is that there's no EMC SAN. There's no Dell great big SAN in any of the cloud providers. And why is that? You ever think about that? Why don't we all have giant storage that looks just like enterprise? The problem is that we have data volumes that are gigantic, thousands of customers in a shared environment. And to provide a safe and secure and a replicated world, everybody's pretty much doing the same thing. We have a large distributed file system. The scale, so I didn't tell you about myself. I worked at Microsoft for about 25 years. And I spent about 5 years in the SQL Server team. I worked on Windows 95. One of my best times was I worked in SQL Server, and I managed the performance and the scale of that product for a number of years. And I also did distributed computing stuff. You know what a database is? It's just a cache on top of storage. That's all it is. There's nothing really fancy. There's all this, the world started off as just a file, and they wanted to index it, and then they said, we should have a query language. And eventually we ended up with today's database world. It's a big business. Fundamentally, it's all about storage. When you move to the cloud, and I worked on the SQL team for a long time building the performance and working with lots of large customers, most of you guys, you get to the cloud and the data volume is orders of magnitude higher. And we have, every day we're building 6 gigantic data centers at every point in time. And a lot of that is storage. So the storage architecture makes it a real challenge. Latency. The problem that we have with latency is that, as the compute and the storage and the silicon infrastructure has been continuing to grow, what we've all seen is that the bandwidth to get stuff in. I was in Washington, D.C., meeting with some customers last week, and the guy said, all of you guys, it's like a roach motel. The data goes in, it's hard to get it back out. So we've actually acquired a company to make that a little less trouble for you guys, but there is this problem, right, where the data and the compute, do you want to move the compute close to the data or the data close to the compute when you're using one of our offerings? That's a challenge, right? It's not obvious where you should go. So we've been working with a number of customers. We've got some scenarios and use cases for kind of all of the 3 top things that that have been presented to us at least, which is seismic, reservoir, and computational chemistry. And again, I'm going to go through the scalable range of offerings that we have, and we're I got to say we're on a journey with you guys. What we really want is to have an opportunity to learn, and one of the things that since I'm the manager of all of these kind of things, all these GPUs and Mellanox stuff and all this, Intel, AMD, whatever. I know every couple of weeks or so we look at, well, what do we want to do next? And so, as you work with us, feedback about what we should build is super helpful. So again, our specialized compute. So the Azure fleet, has the kind of VMs that you guys don't want. These are all of the general purpose. There's entry level for dev test. We have a series called the D series, which is useful for kind of common applications. I've got a bunch of customers in embarrassingly parallel that do 10 to 50,000 cores. They do modeling of financial services, risk, things like that. The F series, we just introduced a Skylake F series. We got large memory, get lots of IOPS out of storage, and then we have these storage optimized virtual machines. But the ones that I manage, the ones that are my team, are the H series. So these are the high performance VMs for batch processing, fluid dynamics, Monte Carlo, the GPUs. And one of the differentiators for us is that we've built all of our specialized compute SKUs mostly, and we have a Mellanox InfiniBand as a second backend network. So we get low latency relative to normal Ethernet and high performance. We sort of announced, and actually I just saw on the wall outside, the guy that announced it last year at Hot Chips, Doug Berger, is one of our researchers. We're just about to announce an FPGA-based inferencing service. So inferencing for image classification. And the other thing you may have seen is we have announced that we're working closely with Cray. And we have the ability to bring a Cray XC series, whatever you want, into Azure also. And between all of these things, we can, the one on the far right on the bottom, that's the one that allows us to get into a decent conversation with you about seismic. Reservoir sim, that one's pretty straightforward, as you guys probably all know. In terms of the feeds and the speeds, we can do that with an Intel processor, InfiniBand, a couple hundred to 1,000 cores. Not a problem. We can do the remote visualization. We have all of the right stuff for doing that. Plus, we've also got all these GPUs that we're building out literally as fast as we possibly can. We've not seen the organic demand curve for those yet. Everything in GPU land sells out. The first cluster went out in December of 2016, and I got an emergency escalation 6 hours later saying that there's something wrong from the cluster because it's sold out in 6 hours. And then it's every one of those. This is, remember that slide where I said everybody wants to put AI into stuff, and even if they don't know what it means? Everybody's trying it. The H series, so here's a little bit of a deep dive into that. So we actually are working on the next generation, the Skylake ones, and also the other vendor down in Austin. So we've got a dual core, two 8-core processors, 2-socket Haswell. It has 224 gigabytes of memory. There's a second backend network. So the way that our world works is that we're not IB only, right? Because IB is not encrypted. It's hard to make it secure. So what we've built is we have built a system that when you ask through the portal or the command line, hey, I want 1,000 cores, what we do is we allocate those on this cluster. We whitelist it, create a private network on the IB. So we've fully populated the IB. We have 2 layers of switches. And so we can be almost bare metal with no noisy neighbor problems when you're running a single job. And then each one of them has 2 terabytes of SSDs. The way that we built it is we have a kernel mode bypass. And we get about 2.6 microseconds of latency doing a ping pong. About 3 gigabytes per second non-blocking. We're about 90% efficient on LinPack. So we're in the ballpark with kind of your typical Intel, Mellanox, HPC cluster. I'd say the bulk of my customers are doing finite element analysis, reservoir simulation, computational fluid dynamics. Basically fluid, there's a lot of fluids in the world. So the CFD is a pretty big workload. And so we've got a bunch of customers there. Here's an example just showing NAMD, molecular dynamics. And then Cray. So this is like the highest end offering that we have. This one is one where You make a commitment, and it's a dedicated cluster, but we can build that in our data centers, so it's either XC or CS Norm. And it's built to your specifications, and this is where what we've got is the customers that are buying these are actually quite a, there's a number of folks in your industry. I was in DC, and pretty much across the world where everybody has been a Cray customer. They're saying, hey, look, what I want is I want to be able to get that Cray closer to the things that are important in the modern world. Where, the thing that I haven't been in the HPC world for that long, but one of the things that I noticed is that most HPC departments or groups or collections of people, whether it is a university, a national lab, a government customer, oil and gas, that organization is distinct and separate from the rest of the company. And you like it like that. You have created a bubble. And that bubble isolates you from the whims of IT. And you have sold the benefits of all the algorithms. And we're the only ones that know how to do InfiniBand. We're the only ones that know how to build these giant clusters. And 2 megawatts, not a problem. That's my domain. The problem with that, and you guys all know this, right? And the data analytics is not your domain. It's a little different. Structured and unstructured data, 50 to 100 petabytes. Interpretations from 50 years ago on pieces of paper. Do you want to go back and get that data? Do you want to make that useful? Yeah, of course. But it's a different world. It's a little bit different. I have bad news. You're going to have to work with the rest of the IT org. It's not just going to be HPC with the guys with the pointed hats and the comets and the little, wizardy thing. That's not going to be the future. And it's not because it hasn't been great. It's just that, as we all know, we need to combine the telemetry, the physics-based modeling, and the AI. And we've got all this structured data, and mostly we have unstructured data, and a lot of it is scanned. I've had the opportunity to look at the data models from a number of customers over the years. Don't worry, yours are not any worse. Nobody's good. Everything is a mess. There's only one kind of data model that seems to be there. Large, unstructured spaghetti. No one can figure out what it is. That's all. But there's something in there that I need. So that's where we're going to go with that. And the reason, Cray is headquartered in downtown Seattle, and we're on the east side of Seattle. And so we know these guys really well. We trade employees back and forth. And a couple of years ago, I said, we should get a Cray in Azure. And I went over there, and they were like, no, the HPC world is completely separate from everything that you do. We have no need for the cloud. And then they went to SC16, I think, and they got hammered by their customers, and they came right out and said, hey, why don't we do a deal? And so what we have is we have this. I told you we're not going to get a slick marketing pitch. I'm the dev manager here. But the cool thing about this is that it gets you to put those multi-stage workflows. You can do dev test on it. You can do visualization, AI, and analytics. The other kind of neat scenario that we're working with some customers on is the XC plops in, and then they want to burst out to our normal HPC stuff. The hybrid scenario where you burst, how many times have you heard that one from us? That's probably, everybody's sick of that one. And it works, but it's not particularly compelling because, I think most of the work in the oil and gas industry can be predicted on a longer time scale than what I see with car companies. So car companies have, oh my gosh, we have a 2-year backlog to do crash testing. So, can we rent your cluster for a year? That kind of stuff doesn't seem to happen so much here, although maybe, if you guys here's what I think you're going to want to think about. If you want to embrace kind of a radical agility in your world, you want to at least dip a toe in the water with us or one of my competitors. because we're on a really fast train. I'm buying, and my competitors and everyone's in the industry, mostly we're buying the very latest, and we're experimenting with the newest, and we're trying out all kinds of different computing and programming and infrastructure and hardware. I have a fairly large team, and we're bursting at the seams with new stuff that's coming out. And you guys see it all too, because all the vendors come to you, they come to me. I'm trying it all out, and if it's going to work to improve a high-performance computing environment, I'm going to deploy that in Azure. So that was the H series. The GPUs, we have a range of them. Probably we have more than anybody else. I won't go into why, but we do. And visualization, rendering, HPC, deep learning. So the first one we have, this one's for visualization. So we have a VM type that has two Maxwells, two M60 cards. So basically, you can see. So we've divided it up so you can get one physical GPU, 2 or 4. I think my favorite story is a large catalog company. It takes about 1 gigabyte full bleed for Adobe applications like InDesign to show a page, and this one has 224. They would never buy a 224 gigabyte workstation for a graphics designer, would they? No one ever would. No, and they wouldn't put 4 GPUs in one of those. That's a pretty expensive computer, and a graphics designer would not deserve that. They would not. However, they will rent it. And this company has been renting like about 300 of them since the day one. This is when we launched this customer, they bought the whole cluster on the first day, and they said, oh, we're going to use it for a week. They've never given it up. It's pretty compelling. You can flip through the pages on this catalog in real time. And you don't have to wait. That's another benefit, right? Well, I can build stuff that you won't buy for your engineers. The next series that we released, and we released the M60 and the K80s at the same time, and now the K80 is ancient. I remember when I was going to SC16, everyone was all excited about the K80. Remember that? Oh, we loved the K80. It was so cool. A little bit low on the memory, remember how that, it was a little bit compromised with the bandwidth because it's sharing the PCIe. But by and large, a very cool thing. Now it's just old hat. Of course, we have to go beyond that. So we have P100s. One of the things, let me go back a little bit here on this one slide too. On our K80s, we made the decision to include InfiniBand. Because when we talk to people, and I mentioned before, we have 5,000 researchers in MSR, and they're pretty influential. They're in my office a lot. Not all of them, obviously, but I got a lot of these guys in my office all the time. And they're like, we want to do large distributed training. And so we typically do about 128 GPUs. And so we want to be able to support that. And so what that means is that you need another, I guess, high speed, low latency interconnect. But when you're doing training and you're doing stochastic gradient descent, right, you have to shuffle the batches around, right? And so there's a big data throughput problem. P100s, pretty obvious here. So basically, this is another Haswell. It has, if you get the whole box, what you're getting is you're getting 24 cores, 4 P100s. They're PCIe connected, a bunch of memory SSDs. And so this one's been very popular. People have been doing, if you guys are TensorFlow fans, you kind of realize that it's distributed training kind of doesn't work very well. But a 4 GPU works really well with TensorFlow. So multi-GPU, non-distributed. So that one has been very popular. We also have our Voltas out. We went to general availability at the beginning of March. And we're still, I think, a little bit early in the days of of Volta. I think, does everybody here have one? Or multiple of them? It takes quite a bit to actually unlock the full advantages of the architecture, but it's a very important architecture. And we have been working closely with NVIDIA to ensure that we have this. We've announced, we haven't got in production yet, we're going to do NVLink-based one with 8. So we're going to have an 8 V100 with NVLink. Right now, that's close to being done. Here's where the MSR researchers came in. They wanted us to do the P40. And the P40 has more memory on the GPUs, and there's a pretty significant advantage to large distributed training. Okay, those are my parts. Those are the feeds and the speeds. I've got 9 minutes left. I'm going to try to finish this up in 4 or 5 and give you guys an opportunity to ask questions. So I think everyone's probably seen this. There's a bunch of different models and ways to think about, if you're on premises, and this is the one that works, I think, really well for oil and gas, to do a hybrid kind of a burst scenario. And basically, you can burst with this company that we just bought. So we bought a company called Cycle. I think these guys have maybe known by some. So we bought them. Their engineering team reports into my world. And I think it goes without saying, that the HPC world is all about Linux and open source. And so we work pretty closely with all of the Altair, Slurm guys. We have an old thing called the HPC pack. Surprisingly resilient. Once you sell a bunch of something, you can never get rid of it. And so you can extend your cluster to the cloud to handle this kind of peak demand. Lift and shift. This one's actually, I think, fairly difficult in the oil and gas world. Because once you lift and shift, you gain all of the latency disadvantages and very few of the kind of performance advantages that you get in an on-premises HPC world. So this is not one that I recommend too much. The other thing, too, that I think I'm not going to touch on very deeply, but the economics, if everyone that I know in this room runs their clusters about 80 to 95% full all the time, right? So either they're fully amortized or you're getting all of your money's worth out of every penny that you spend. And so why would you want to come to us? And I think the reason is we have some things that we're going to be, we spend a huge amount of money on capital equipment. My stuff looks big. It's a relatively small, as you know, part of the total IT spend. And if you look at HPC, the total IT spend in the world is not that large of a fraction of that. That is mirrored in Azure. I spend a huge amount of money every year on new stuff. It's dwarfed by things like the D series, which is just an undifferentiated CPU. But one reason to think about working with, with the cloud providers is if you want to get on the journey, influence us. And also, I do have a whole bunch of new stuff in the pipeline. The final one is like cloud native. So one part of my world is we have built a totally cloud native scheduler. It's called Azure Batch. And the cool thing about a cloud native scheduler is because if I need to do more work right now, I can just allocate more virtual machines. It is the simplest scheduler in the world. It's a greedy, first come, first serve. That's all it is. There's no complicated policy because you don't need it. We have a little language with a set of rules that if the queue grows, just allocate some more VMs, create a larger cluster, allocate another MPI cluster. So that's actually kind of a thing of beauty in a way. This one is mostly used for embarrassingly parallel. Our launch customers were in financial services, doing insurance risk, mortgage pricing, all kinds of stuff where, basically Monte Carlo analysis. If there's a lot of fluids in the world, there's also a lot of Monte Carlo. If you look at the number of CPU cycles that are spent on fluid dynamics and Monte Carlo analysis, there's probably a lot more on Monte Carlo right now. I think if I look at the various insurance companies that I'm also the sponsor for, we're probably looking at, like, the bulk of the world is looking at Monte Carlo analysis for pricing almost every single thing that you purchase from an insurance company or a financial services firm. Everything. Nothing is priced in the way you think it is. So if you look at the bottom of the slide here, we've got, let me just go ahead and put it all in here. So Azure Batch, so basically you've got the hardware, VMs, and then what we've built is we built an ecosystem around this cloud native thing called Azure Batch. And so we've got, in terms of the feedback we get, so we've got a bunch of customers that say, hey, we want to be able to get Spark, R, and training, and just regular old compute all together. What we're trying to do is we're trying to break the mold. And what we're doing is we're building these multidisciplinary small teams, and they're solving problems by bringing in data science, machine learning, with traditional physics-based modeling. And that has been a really successful journey for a number of my customers. We also, as I said, we bought this company, Cycle. And so that's an experience where basically it makes it really easy to build kind of this repeatable hybrid HPC. The scenario that we see that's over and over again is I have my on-premises stuff that's not going to ever go away, and I want to be able to burst to the cloud. That one actually works quite well. And so what's kind of cool about Cycle and why I really like the people, and I really like buying the company, and we work really well together because they have a nice kind of metaphor around templates for clusters. They support kind of all the open source stuff that we love. Then there's this other service, so you can see where I'm going, right? We've got the hybrid stuff. I've got the AI. And so we built on top of Batch a managed service that does the cluster management and job scheduling. So you can use any toolkit, TensorFlow, CNTK, Caffe, Chainer, PyTorch, whatever you want. And what people are doing is they run experiments and they do hyperparameter optimization. In the HPC world, that's a parametric sweep. But a hyperparameter optimization is a search for the knobs. What are the right set of knobs to set when I'm training? And it turns out that if you have just a regular computer, running training will give you an answer. And if you've done a lot of things like classification and object recognition, it's not very hard to get to 80%, is it? That's easy. Do you want 80% accuracy in anything in production? No. Right? You need like 99, 99.5. But people are they're willing to live with 97. So this is basically, you just submit it through the Python or a portal or whatever command line. And it also integrates with Azure Machine Learning, which is kind of the traditional machine learning kind of stuff, logistic regression, that kind of stuff. Here's an example I pulled from one of our customer cases. So there's kind of two things right now in the world of machine learning that work, and the rest of it's kind of hype. I'm sorry from the people that are doing the other things, but the ones that are in production, because I've been in production with hundreds and hundreds of customers for the last 18 months. It's image classification and object recognition. All that stuff is mature, it works, and you can actually be productive in almost any organization if you can think visually. Humans do a lot of dimensional reduction, right, when we think about things. If you think about math problems, there's no limit on the dimensionality, but when humans need to do something, we have to think in terms of 2 dimensions. That dimensional reduction is actually pretty advantageous when you're doing things like image recognition and object detection. I think I'll skip that slide. That one's pretty obvious, right? Basically what we have is, this is where the data analysis, other kinds of compute that go next to the HPC world. And this is an example of a very important slide. It puts HPC at the center of the universe. So that one's important. So everything else is less important, but you kind of need to think about it. We also just bought another company called Avere, and they build both a hardware and a software appliance. Since I'm about out of time, this one's very cool. They have a bunch of customers that have multi-petabyte data sets, and then when they need to do a unit of work, what they have is, the size of a particular simulation or a rendering of a movie, is in the terabyte range. And so they have a hardware and software appliance approach that allows you to store all of that stuff on premises, use networking to get it into the cloud, store it in the cloud, use a virtual appliance, and what you can get is you can have the storage on site with an appliance and reach into your data center to pull out just what you need, or you can move it into the cloud, store it in a blob, and if you look at everybody's pricing, blobs are cheap, and what you really want is you want an NFS file system that's backed by a blob. And so I looked at these guys a while back, and we went aggressively after them because they solve a really significant chunk of that data problem. Another piece that's really, I think, fascinating for you guys, I heard Azerbaijan a moment ago. For everybody who's in these remote locations where there's data sovereignty or other issues, take a look at Azure Stack. So basically, it provides a disconnected and edge experience of Azure. So you write the application model, whatever app you have, you write it once, and then you purchase an appliance. So basically, it's an Azure as an appliance. And so you can put that appliance in wherever you need to go. So it's very cool. So it can address these real-time latency problems because you can do all of the data collection. Like if you're doing stuff for drilling and you're in the production environment, an Azure Stack gives you the same application model so you can run the visualization, whatever simulation you need to do if you're doing that there. So that I think is a very cool experience. And this is my last slide. So basically, my journey, I'm not the smartest guy in the room about oil and gas stuff. Basically what we've done is we've tried to build a bunch of different pieces of stuff in terms of infrastructure, platforms. We try to make it really easy to do that hybrid switch. Try bursting. HPC with AI. I did put IoT on this slide. I'm sorry. This one, I think we've done a number of image classification, object detection experiments with customers in your industry, and man, it's been really surprising. Like, borehole analysis is not that hard. You have a lot of it. You're spending a lot of money on it, but you know what? I put some really smart PhDs on it for an experiment that we did with somebody in your world, and we nailed that problem last December. We spent 3 weeks. Like, think about it, right? We got the tip, we got the species, we got all of the 3 important pieces out of it with 3 really smart PhDs working with a subject matter expert for 3 weeks. We got a bunch of partners, and this is a marketing slide. So we do have dedicated HPC engineering and customer engagements. That's me and my team, plus we have a whole bunch of Microsoft guys. All right, thank you.